So I'm graphing rational functions, and I want to use a strategy that I have for graphing those rational functions. And the first thing is to determine if we have symmetry. And so I'm going to determine if that function is even or odd. So I'm going to find out what f of negative x is. I know what f of x is. So f of negative x you're just going to put a negative x in place of x. And simplifying that down, you get 3x squared, because when you square that negative x, you get a positive, so positive x squared. And then you get x squared minus 4. So since f of x is equal to f of negative x, we have an even function. And that means it's symmetric about the y-axis. Okay, I'm going to find out what f of, negative f of x is, to see if we have, to see if it's an odd function. So what you want to do here is literally just write down what your f of x is and make it negative. And so that would be 3x squared over x squared minus 4. So that could be thought of as negative 3x squared over x squared minus 4, or it could be thought of as 3x squared over negative x squared plus 4. And in order for it to be odd or symmetric about the origin, then your f of negative x would need to be equal to negative f of x. Well, neither of these are equal to this, which f of negative x in this case is equal to f of x, okay? So we're not odd, and that means that we're not symmetric about the origin. Okay, so next we're going to find our vertical asymptotes. If they're, let's see. So f of x was 3x squared over x squared minus 4. So all I want to do is set the denominator equal to 0. Well, in this case, that denominator can be factored. And it's easier to solve when you factor it. You'll just set both factors equal to 0. So there are two vertical asymptotes at x equals plus and minus 2. Okay, well, what about the horizontal asymptote? Okay, well, the degree of the numerator is the same as the degree of the denominator. So it's really very similar to some of the other ones we've worked. And that's saying y is equal to 3x squared over x squared. We're not going to look at the minus 4. We're just looking at the highest power in the numerator and the highest power in the denominator. And that just simplifies down to 3 over 1, which is just 3. So y equals 3 is our vertical asymptote. Horizontal asymptote. Okay, step 4. Or next thing I want to do is think about the slant asymptote. And there's not a slant asymptote because there was a horizontal asymptote. And in order for there to be that slant asymptote, the degree of the numerator has to be 1 more than the degree of the denominator. Well, that would mean the top is heavy. The top power would be greater than the bottom power. And that wasn't the case. We didn't have a horizontal asymptote. I mean, we had a horizontal asymptote. And if you have, if you're top heavy, you won't have a horizontal asymptote. Anyway, hopefully I didn't confuse you there. From here, I'm going to kind of get ready to graph, but I do want to think about maybe some other points. But I'm going to get ready to graph, and that will show me where I need to find some more x and y values at. I have horizontal asymptotes at positive and -2. So let me get those dotted lines going. I don't really like that one. Let me go back and make it dotted. Okay. Okay, and then I got the vertical, excuse me, these, I think I keep on slurring these words. The asymptotes at positive and -2, those are vertical asymptotes. The horizontal asymptote is at y = 3. And these need to be dotted lines, okay? So, and you want to know what? I didn't find the x and the y intercepts. But let's just go ahead and look at what that would be. I knew there was a step missing in there. So x and y intercepts. What happens with those is you plug 0 in for x and 0 in for y. Well, when you plug 0 in for x, that would be 3 times 0 squared over 0 squared minus 4. So you get 0. So that's both your x and your y intercept. So we got this point going on right here. Well, I need to figure out some more things that are happening. I think I'll plug in x values of -1 and 1 to cover this area right here of the in between those vertical asymptotes. And then on this side, I think I'll do, let's see, -3 and -4. And I'm running out of room. I'll also do, let me extend over here. +3 and +4 to cover this side. Because it's like boundaries, okay? So, okay. When I plug -1 into the original function, I get -1. When I plug 1 into the original function, I get -1. When I plug 3 into the original function, it's 27 over 5. Or you could think about that as 5 2/5. If I plug in -4, I get 4. If I plug in 3, I get 27 over 5 again. If I plug in 4, I get 4. So this is interesting. Let's look at how this works out on the graph. So when I plugged in 1 and -1, I got y values of -1, so these points right here. So it looks like the graph right here is doing this number. So now, if I plot the point -3 and 5 2/5, so 4, 5, 6, we'll just call that. Okay, so this is -3, and we get 5 2/5 for the y value. And then when I had -4, I had 1, 2, 3, I had a y value of 4. So that would be about like that. And then the same thing happens on this side. When I had +3, I got 5 2/5. And when I had 4, I got 4. And this makes me happy because it shows that symmetry that we found in the y-axis because of the even function. If you look at this right side of the y-axis, it's symmetrical to this left side of the y-axis.